Hi, so these are the answers to the questions for the coefficient of friction lab. Question number one states which combination of materials had the highest coefficient of friction and the lowest. I have my data sheets right in front of me. The highest coefficient of friction was when I had the wallet was my object. The wood was the ramp, and I was acknowledging static friction. The highest of the three trials I got was when the height and the length of the ramp were 51 centimeters, which made the coefficient 1, and the average of all three trials was 0.99. The lowest coefficient of friction, I guess, is this one. When I had the wood, when I had the wood ramp, the calculator for my object, and we were looking at kinetic friction, the average of that came out to be 0.54. What type of friction? Question number two is which type of friction is always the greatest, kinetic or static? Why? Oh my gosh. Static is always the greatest because static always has the potential to be more energy, whereas kinetic, you already know the amount of friction being placed between two objects, so you know what the limit is. Whereas with static friction, you know it's only the potential to do much more than it could be. What effect does surface area have on the coefficient of friction? You may need to research this if you do not know the answer. I said surface area. It has a big difference because whereas with the surface area of this for example. So here is the calculator I used for my object, for my third object. This had, well, here I'll say the example for kinetic friction. The height of the ramp was 35. Well, the coefficient for kinetic friction for the calculator was 0.57. With the had an average of 0.54. Whereas with, so that was with this calculator. If you had a littler calculator made out of the same material, both made out of plastic, I could have had a higher or lower coefficient of friction just because the size of the object was much more different than this calculator. So it could be the same material, both the ramp and the object, but the size definitely plays a difference because the bigger the object, the more, like with the perpendicular component, it's already pulling down more, but with the lighter object, it's not pulling down as hard. Excuse me. So yeah, the question number 4: research one of your combinations online to see how close you came to a published coefficient of friction. Here's one site you can use, Engineer's Handbook. I looked online and I couldn't find anything with that link, but I found something else. I actually found an experiment that a student did very similar to this. The three objects, well, he used four objects, but three objects he used a book just like I did. He used a shoe, I think like a 5 pound weight, and I forget what the other object was. But what stood out to me was the book because he and I had the same object. The book he had was a little bit bigger than mine, so the data was a little bit different than what I had, but it was relatively close for static. For the book, the average coefficient of friction was 0.6967, and the coefficient for kinetic friction was 0.7. And because he had the heavier book, he had excuse me, because he had the bigger book, the numbers were different, but they were relatively close. I think it was only like 0.05 off at most. I have so this is only the answers to the questions. I have the actual lab itself on the other video, and my other data right here to, I'll be uploading that to the Dropbox soon.